Okay. Just it works?
It works.
Very modern. Wow. Well, welcome everyone to this fourth?
Number four.
Number four, yeah. Valencia. Well, we are one of the organizers, Marcelo. We have Chad. We have Jad and Bernardo. They need to go there because Jad is kind of injured. And we thank you for the opportunity to make this event here this day. And that is something that I never understand. I was talking to someone. Why we are in Spain, in Valencia, we always do the event in English. Why not in Spanish? So I give a word to you.
Sure. So hello everyone, my name is Hani. I work here at the IBM Digital Center. The center has been here for a year. We're very, very pleased to have you here. It's a great opportunity for us all to network, to learn, to get the opportunity to basically hear from the speakers. Thank you, Shani, as well for coming. And we have also Nelson from Red Hat who's going to be speaking. So looking forward to speaking to all of you. Get to know people that basically I moved to the city like 6 months ago. So excited to get to know the tech community here. And I think this is just an experiment, basically, Marcelo. So hopefully we'll do more of those. We'll get bigger rooms even. So looking forward to that, and thank you all.
Thank you.
Yeah.
Do not offer because we use it.
We enjoy it.
Thank you so much. So let me just press some slides. Well, I believe that everyone is here. I already know what is CNCF. Please, our ambassador from CNCF.
Yes, I'm CNCF ambassador, so I can, I guess, speak on behalf of, what is CNCF? It is a mechanism to host open source projects, most notably Kubernetes. And there are over 250, so I won't go through them all. But we're here because of the CNCF and spreading the open source and cloud native love. And go ahead.
So, well, would like to say something more about it?
No, I think, who has never heard of CNCF? Raise their hand. Okay, so I think we're good.
So the idea that Chad explained a lot about it is to bring this knowledge and create a community here in Valencia. So we are glad that every time we enunciate that we have an event, a lot of people call us and say, hey, I'd like to go there. So for now, we don't have a big room, but now I know that we have biggest. Well, good to know because we can invite a lot of people. And yeah, and if you would like to know and to be aware what we are doing, you can follow us in this place. And of course, thank you again for the space.
Yeah. Mirror? No. Okay, cool. So let me go. The first one. So this is Nelson. I'm currently working at Red Hat as a specialist solution architect in the AI ecosystem. I'm posting my LinkedIn profile in case someone wants to chat about anything. I have this presentation which is around 100 slides. So I reduced everything into 30 or so because of the time. So I'm going to be super fast in the topics. But if anyone is interested in knowing a little bit deeper, we can talk later or offline. Does anyone know anything about vLLM? But nobody uses vLLM? Nobody works on AI? Right? Okay. So vLLM. vLLM, what its goal? Is to be the fastest and easiest to use inference engine for generative AI. We have two different types of artificial intelligence. Everyone nowadays is talking about generative. So if you want to run a model that came with generative intelligence, you need to use something like vLLM. So far, I think it's the only one that it's been used in the market. Maybe there are some others, but I'm not aware of any. So that's the goal, and how it's doing. It's currently the most engine used for generative AI. It has a lot of companies contributing to the code. We have Meta, DeepSeek, IBM, Red Hat. So almost every big tech is working on it. It's pretty simple. You have the repository over there. If you want to take a look, it's pretty simple to use it. You just need to run a pip install and you have it. And then you just need to run the standard vLLM command to be able to inference a model. By the way, does anyone know what inference means in this? Yeah, everyone is aware? Okay. The inference is when you put the model that it's able to receive requests and it's able to process them. So you can have model, it's a package, and until you don't do the inference, you are not able to communicate and get replies from the model. So it's the time that you really get value from the model. You have, for example, in predictive, you need to spend a lot of resources building a model from scratch using any machine learning techniques. And until you don't inference the model, you are not able to communicate and get value from the model. Okay? So you can do that using the vLLM serve. In other talks that I do around the topic, I usually say that vLLM is the inference engine, but it has more things inside the project that we will take a look at a little bit later, because everyone used to know vLLM only as an inference engine, but has other features that are important, and we will take a super quick look on them. It was ranked as one of the top community projects in 2025, and how to run it. Okay, it's just pretty simple. Run the pip install vLLM and run it. It can serve any kind of model that it's generative. I'm saying a lot of generative because we have two types of artificial intelligence. It only works with generative. So other models that are standard machine learning models cannot be run in vLLM. And it supports any kind of GPUs or accelerators. You can run it in AMD, Intel, NVIDIA, wherever. Important, you don't need a GPU at all. It's better if you have it because it's going to be able to process the request in a fastest way and you are going to get better performance, but you can even run some models in CPU only mode. So if you have your laptop, you can give it a try. Don't recommend it for production environment because the performance is pretty bad, but in case you want to do a few tests, you can do it in your laptop. I will go through the entire ecosystem that is around vLLM in a super fast way. As I said, this presentation is made to be done in more than an hour or even 2 hours, depending on. So I will just mention a few things about any of some of them. And by the way, I didn't know that the talk was in English, so I prepared the storytelling in Spanish. That's why it's not that fluid. I can speak English, but I prepare everything in Spanish, so it's a bit more complicated. So the core, when you do inference of a model, you need to take into account a lot of things. For example, the model architecture, not every model it's built on the same way. So you need to be able to inference models that are created in a different way. You need to take into account the parallelisms in terms, if you want to get better performance and you have more than one GPU, you need to be able to combine both at the same time to be able to process the request, the way to optimize, and all of around parameters. I'm going to ask again, is someone working with AI or doing something AI related? Kind of? Okay, because most of the things that I mentioned are just related with AI. For example, the parameters that if you are not aware of them, I'm not going to go into details right now, but it would be interesting to mention. For example, you have the temperature of each one of the parameters that you can define when you run a model, and it helps to define if the model is going to make up things or it's going to be more precise. So depending on the temperatures you define, you can create a model that creates poems. So for that kind of project, you need to have a higher temperature. But there are thousands of different parameters that you can configure when you run a model. This is how the project evolved in the last year and a half. At the beginning, it was not able to do almost anything. And now, as you can see, everything is green. So it's growing a lot. And that's mainly because all of the highest tech companies are contributing to the project. It's growing a lot. You can take a look to the repository. But as I said, NVIDIA, AMD, Intel, Red Hat, IBM, almost everyone is contributing to the project. And it's nowadays the standard to run those kind of models. So I don't think there is any other engine to run these kind of things in production. Speed, so vLLMs, it's continuously improving the accuracy and the performance. In this case, you can see how the DeepSeek, does anyone know DeepSeek? One of the models from China. So they did some tests on how to perform using vLLM and without using vLLM. And as you can see, it's faster and the accuracy is even better using vLLM. Distribution, it's important because the way that the GPU works, it's a little bit different from the CPUs. If you have a GPU that is attached to a model, even if the model is not using the GPU at that moment, it's going to be blocked for the use of that model. Then you can work on slicing the GPU and do things like that. But if you have a portion of the GPU that is associated with a model, that portion is blocked. So it cannot be used by a different model. In the CPU, you can have the overcommit and they kind of mix between them. So to improve the usage of the GPU, you need to work on the parallelisms. vLLM supports any kind of parallelisms like standard development. But the important one here is the disaggregated PD that we're going to check now. Profile and the code. There are two things that are super important when you are working with the AI. Profile, it's the process where you start to understand the prompt. So you have you are talking with ChatGPT, for example, and you send a request. The first thing that the model needs to do is to understand what are you saying. So that's the prefill stage. And then you have the decode. The prefill needs a lot of computation. So it's the process that takes more GPU. And the decode, it's the part where it's starting generating the tokens and it needs more memory. The problem is if you are running both processes into the same GPU, they are interfering between them. So you are not getting the most of the GPU. With LLMD, what you can do is separate them in different workers. So you can use a part of the GPU or one GPU to do the code and the other one to do the prefill. And that helps to get the most of the GPUs that you have. I don't know if anyone tried to buy GPUs. They are super expensive. So you need to use them in the best way as possible. If anyone is interested, what it does, and we will take a look a bit deeper later, it uses the NixL connector to share the cache across different nodes. But then I have a diagram. Multimodal is the same problem. If you have a model that it's able to work with images, voice, and whatever, it needs different ways to process that information. So using vLLM, you are able to run some of the tasks, for example, to understand the images in one GPU and to understand the voice in a different one. And that helps to improve the overall experience of the accelerators. I have here, I don't know, the slides are going to be shared with.
Yeah,
okay. That's an interesting blog about how that part works. And the reasoning learning, vLLM, it's mainly an inference engine, but as you saw, it helps on the orchestration part. And since not long time ago, it's able to participate on the training part. Does anyone know what training a model is and how it works a little bit? Okay, so usually the ROI, so the return of the value came from the inference, but sometimes you need to train the model. You can train or create a model from scratch if it's a machine learning model. If you are using generative, you can do something like RAG or fine tuning, which means adding more information and personal information to the model. So regarding that topic, it's able to do rollouts on the model. Say that you have a model that it's trained with general data and you have new data nowadays and you want to promote the new version of the model, you can run the rollout. So the process that was being processed by the old model are going to be finished, and once those are finished, the new model will be deployed, so you get the zero downtime when you are updating a model, for example. Quantization. Does anyone know about quantization? Okay, I'm more used to, since I'm working in the AI ecosystem, I think that everyone knows about the AI. But okay, quantization. Has anyone tried to deploy a model? There are models, if you go to Hugging Face, there are a lot of models that are available for free. You can try to deploy them, but some of them you need maybe 8 GPUs, 4 GPUs, depending on the size of the model. And in most cases, you don't need a model that is that big. For example, I always put the sample of ChatGPT. I can ask ChatGPT to organize a trip to Valencia, the same as what is the best way to do a presentation or thousands of things. So the model has a lot of general information that is usually not very useful for a company. So what you need to do is try to add your own information to the model, and it will be a specialist of your company, your department, or even your personal information. Quantization is a way that you take the big model and you try to change the algorithms and the way they are connected between them to reduce the amount of hardware that you need to deploy the model. So you can deploy pretty much the same model, but instead in 4 GPUs, in just 1 GPU. And since the first model is super generalist, the new one, it's generalist, but it's not that big. So you can, again, take more advantage of the GPUs. And in terms of quantization, it's a little bit that you map the way that the model was compressed in the first way, and if it has fewer bits, it will be faster to be logged. To do that, you can use LLM compressor, which is one of the frameworks that it's available in vLLM. And there are some models that are already quantized, not to do Red Hat marketing, but this is one of the repositories in Hugging Face. Do you know Hugging Face? Hugging Face is one of the repositories for the model. There is a repository from Red Hat that you can see the models that have been quantized and the process that they run to be able to be quantized. So you can try to replicate that in your own environment if you want. Do the quantization process takes a lot of, you need a lot of GPUs to be able to do that, and it runs complicated algorithms, so it's a complicated process. But if you want to take it a look, LLM compressor is a free framework that you can give it a try. In the repository, you can see how the models behave before and after the quantization, and you will see that the accuracy in most of the performing layers are pretty much the same. If I have, yeah. Let me show you super quick, because this part, I think it's...
You have fun.
Yeah, I know. It's pretty important. For example, the QN, which is one of the Chinese models as well, you see the benchmarking that was run against the model after and before being quantized. And in most of the cases, it's pretty much the same. So it usually makes sense to try to use a quantized model. Inference, it could be like a Kubernetes cluster in which you have different nodes, and in each of them you have different GPUs. You have in all of them vLLM as the inference engine, and you have different models. What happens if I'm starting to create an application, or I'm just having a conversation with one of the models that it's deployed here, and tomorrow the model was moved to a different node? You need to reload all of the context that has from the previous day, and that takes some time and takes some resources. So what LLMD does is to create a cache across all of the nodes, and it doesn't need to go to the old GPU to ask, hey, what that person asked before. So the context is present in all of the nodes. That makes to be their response faster. In some cases, it's around some seconds. It doesn't seem to be a lot. But if you start creating a lot of agents, or you have a lot of applications running queries against the models, it will be an impact. And that's how it works. So you go to the gateway, and instead of being redirected to one of the models because of nothing, it will see what is the GPU that has less work to do, the one that is free, or if one of them is super busy but has the context, it will share the context with the rest of the nodes. It's a little bit of the same. And we have 2 minutes for questions, if there is any. I know it was super fast, but go ahead. 3 minutes. Go.
So to take care of.
But vLLM is like the general project, and then it has some sub projects. One of them is LLMD. One of them is Guide LLM. Another one is the compressor. So they are not part of vLLM as a whole. You don't need to, for example, run vLLM and then retrain the model. You need to use any of the other frameworks. On the first one, I think those are part of the vLLM ecosystem. So vLLM is known more for the inference engine, but my idea is to try to show you that there are more small projects inside that you can use to do different things like that. So related with the last one, you can do different things. Working on the auto-scaling, you need to do extra configuration, but it will work in a similar way like this one. First of all, you will need to probably have GPUs that are free, or you need to work with a pool of GPUs, and LLMD is the gateway. So once it receives requests, if you have configured auto-scaling and you have free resources, it can create a new node that will redirect the request. Because this is the gateway.
Thank you so much. We have 5 minutes. We can grab some water, go to the bedroom,
Yes,
to the next.
Okay, so nice to meet you. I'm Shani Kazaz. I'm working at AWS. I'm a container and serverless specialist. I'm a BD specialist. I'm leading the agentic transformation in EMEA. I led the platform engineering motion until recently. I'm a mother, I'm a foodie, so when I'm not working, I'm probably will cook or bake or something. And with me, Javier.
Hello, everyone. My name is Javier Garcia, and AWS is Sunny. But I work as a technical account manager, although I specialize into Kubernetes and containers. And I just realized some meetups enthusiasts, so this is why I'm here.
Cool. So let's talk a little bit about the app that you just use. So we're not going to ask you raise your hand. So we built a cool app that you can use. And this is a really simple app, right? It's slightly more difficult than Hello World app. And it built upon 3 microservices built using Kubernetes. So the vote one that you just met, you will see the result one at the end of this presentation where we will reveal who wins, dogs or cats. I hope it will be dogs. If not, I will be very disappointed. And the worker microservice. And between them, we have the database and a cache. So let's think about how much time it will take to deploy this very, very simple app. Let's start with the Kubernetes. So we will use some YAMLs and we will use Helm, and it will probably take us 2-3 minutes, something like that, right? But let's talk a bit about the databases. And here we're talking about AWS databases, we're talking about Elasticache and RDS. How much time it will take to deploy those databases and connect them to our application. Okay, so if you're a developer and you're working in a big company, you will probably use some pipelines, right? You will need to probably go to the networking team and use the networking pipeline to get a subnet and a VPC or an IP address. And you will take the output and you will feed it to another pipeline. Here it will be the infra pipeline to create the RDS. You will take the output and you will feed it to the platform pipeline to create an EKS or to connect your app or deploy it on top of the EKS cluster. Now, if everything works smoothly, it will take you something like half day or day. And if you already use Terraform, and I guess that you use Terraform. By the way, how many of you are developers? DevOps? Okay, so you use Terraform. Okay.
Good joke.
Probably. CDK? Okay, so you know that Terraform sometimes crashes and we don't necessarily understand why, and then we run it and it works for some reason. So it will take us a lot of time. But this is like really simple app, right? In a big organization, it will take much more. CyberArk, for example, one of the biggest companies in Israel, it took them 18 weeks to deploy a service, and they are very advanced. And if you guys, and if for some reason the compliance pipeline decided that your RDS is not compliant, it will delete it. And if you are lucky enough, you will get the notification. If not, you will get just errors and you will not understand why. And if you think that Gen AI is going to solve it, it's probably not now, because if we will feed the AI model a mess, it will generate much more mess, isn't it? So the question is, our pipelines are the right solution? They are not composable. I cannot use them and build something like Lego pieces, right? I need to do it in a specific order and to feed them with the outputs. They are not self-healing. If the compliance pipeline deleted my database, I will need to relaunch it. They're not keeping the state. Where is the state? In the execution file of the pipeline? Which one? Because the compliance pipeline just deleted my RDS. So where is the state? I don't have any place that keeps my entire state of my application. And I need to use a lot of toolings, right? I need to use, just for this very simple app, I need to use Kubernetes and Terraform, and I need to master those tools, not just to use them. The second challenge that we are facing when we are building things with Kubernetes and other tools or cloud resources is that your application will probably look like your organizational structure. That law calls Conway's law, which is pretty cool. And if we are working in a company that is complex and have hierarchy and multiple levels, so our application will look something like that. And if we are thinking about efficiency, complex doesn't sound like efficient thing. And I don't want my application will be layers on top of layers on top of layers. I need it to be simple and quick. So we are seeing that customers can solve those issues by using a method called platform engineering. Some of you do you have platform engineering in your organization? I see some, okay, ish, okay. So also platform engineering is a word that we are hearing a lot, and it looks different and it smells different, and it's okay because organizations are different. But in all of the platforms that we are seeing, we have three main components. The first one is a self-serve component, meaning the developers doesn't need to reach out to anyone or to even speak with anyone or anything. They just use a simple UI. The UI can be a portal, but it can be a CLI or a class in a code. It doesn't really matter what is that UI. They just need to use a UI and do it independently. The second one is that the company is treating the platform just like any other product that they have. They sometimes even have a product manager to this platform, and the customers are the developers that are using this portal, but they can also be the CISO or the CTO. The CISO can define in one place the security standards and apply it to the whole organization in just one place, and the CTO can decide how a service can look like, and it will apply throughout the whole organization. So this is really powerful. And the last one is scalable. The platform doesn't care if we will have 5 developers or 500, unlike a DevOps, which definitely care if we have 5 developers or 500 developers that needs these services. So we are seeing customers like Sony that got 5 times faster deployments in 60% lower of their cost, meaning in 40% of the cost. We saw CyberArk reduce their time to service from 18 weeks to 3 hours, and Toyota saved $5 million annually by implementing this in their organization. And with the platform, we can actually break the connection between the organizational structure and the team, so we can act independently, but in synergy with each other. So how I want it to look like. Let's move to the solution part, not the challenge part. Okay, so I want from the one hand that the different team will still work independently, separately. They will create their own infrastructure as code, and they will apply it or expose it to the developers. Let's say that I want them to expose this in one place, and I wanted them to use Git repo, for example. I wanted somebody will review it and consolidate everything. So let's call this person a platform engineer. And I wanted the developers in the other side just consume the capabilities, and I don't want them to talk at all with each other. Just do it by themselves. So it sounds like a problem that we already solved. Different groups act independently, but still working together. And we solve it by using APIs with microservices. So I want to use API here as well. And if I'm thinking about what I want in this API, I want it to have an authentication layer and an abstraction layer. I want to apply policies, and I want it to keep the state. And if I want to choose a technology that can do it, let's change authentication to RBAC, and let's use schema validation, and let's keep the state in etcd. And yes, Kubernetes can be the mechanism to create this API to build our platform. Cool. Now, why Kubernetes is so powerful to build those APIs? Because Kubernetes is built with, like, the basics are controllers. And controllers have a very powerful things that they are doing, and we can leverage. So when I'm saying controllers, I'm addressing the thing that we can declare what the state. We're just declaring what we want it to be. We are not stating how it's going to do that, right? Unlike a pipeline where we are just saying what will the process be. The controllers are keeping the current state matching the desired state. So if I'm changing something, or if a pod just failed, Kubernetes will do it by itself. It had a self-healing mechanism that it's built in Kubernetes. And we now can create our own APIs within Kubernetes, right? Nowadays, we have a controller that can order a pizza. I heard about something with the F-16, I'm not sure if it's a rumor or not, but definitely ordering a pizza. So why not managing and launching cloud resources? So AWS have their own open source we developed. There are others like Crossplane that you probably heard of. So ACK, it's the AWS open source AWS product. And you basically can manage and deploy the cloud resources, the Amazon cloud resources, just like you are managing your pods and Kubernetes components. So the same as pod, you can create, for example, SNS. You will use the same commands. You will use the same tools. So everything can be managed through Kubernetes. Cool. So we have now the cache and the RDS managed this and deployed the same as we are deploying Kubernetes. But now we need to think about how many controllers we need to add to Kubernetes controllers. Now we have the EKS, we have VPCs, we have IAMs, we have the RDS, and this is a really simple app. Probably you need S3 or SQS or something. And application doesn't look like that. It looks more like that. Multiple accounts, multiple regions. So we need to manage tons of controllers. And also, we have so many other tools. We have monitoring tools, we have security tools, and not only AWS tools, right? We have also third-party tools. So we solved the problem with and created a different challenge, isn't it? But we promise simplicity. So, Javier.
Thank you very much. So you may be thinking, how do I connect everything and how do I simplify? And this is where CRO comes into play. CRO is kind of the all-purpose glue we will be using in order to manage all these mesh. So just to give a bit of context of what is CRO, the Kubernetes Resource Orchestrator, it started on November 2024. It went open source during KubeCon. And then on 2025, Google and Microsoft joined the steering committee. So we are all working together for this open source. And then on September 2025, we moved it to a Kubernetes special interest group. So very good. We're working on it. Community is working on it. So people, well, customers are adopting it little by little. And we want to show how this works. So Crow, it's Kubernetes native, and it allows you to build your custom APIs in order to offer your developers that difficult infrastructure just from a single API. So it allows you to group up and logically put all these deployment services, roles, etc. together. Before Crow, as Sunny explained, we had like within the same level so many different resources completely unconnected, and you may have dependencies, but they may be just place some reference to another. And this is why we are using Crow to build composable abstractions in order to be able to build graphs, and in order to be able to use, like, as you can see, well, okay, this is not working, but as you can see, being able to pass outputs from the VPC in order to create your EKS cluster, or from IAM to your cluster, or I don't know, to some database, or you name it. And here it's important, being able to connect each other, okay? Now, you may be thinking, cool, this connects things, but how does that work? With Crow, we have resource graph definitions. This is a CRD for Kubernetes, where we group up Kubernetes objects, we can group up cloud resources, and third-party resources, not only from AWS. The idea is that this resource graph definition will be built by our platform engineers or the DevOps teams, and then developers will be able to consume them calling the API, creating an resource graph instance. Whenever a developer calls this resource graph instance, they will get deployed all these Kubernetes services, the ingresses, etc., as well as the cloud resources. So how does it look like for a developer? As you can see, we have this dogs versus cats example, right? And this is one of the instances that a developer would create calling this API. So as Shani mentioned, we need interfaces. This is one interface. Now, what is behind that? How does that resource graph definition look like? How was that built? As you can see, we have this RGD, and you place metadata, you place specifications, and we will be reviewing one by one, so do not worry. Syntax always can become tricky, but do not worry, we will break it down easily. We have specs. These are the inputs, so the different variables that we may require. We have statuses. These are the outputs, so whenever we need to connect to, well, reference, I don't know, an instance ARN to whatever other place. And then we have the resources. What are we going to deploy? So let's go with the inputs, with the specs. So we can have different kind of variable inputs. It can be strings, it can be integers, it could be arrays, maps. Then we jump to outputs. Outputs look something like this. Pretty much weird, but with AI, it's simpler to create. Okay, so do not worry, you don't have to remember. And these are just, for example, endpoints to your RDS, secrets, etc. And finally, resources. For resources, we have, as I said, Kubernetes resources and cloud resources, but you can integrate also third-party resources, okay? And even other resource graph definitions. And an example of resource, let's go for a subnet group. You see here this ready when, this comes the dependency. You can see that we require, or we have been, well, we will be building this upon something happens, the dependency. And then we have the kind which in this case is an ACK controller for RDS, as well as other specifications, so inputs. We jump to another resource, now a DB instance, and it's the same. We just have some definitions of the kinds, what ACK controller are we using, and whatever other specification or output we require. And if we come back to the triangle that Shani highlighted before, we had that part of self-service as a product and scalable. Why? How can we get this? So it's self-service because it's easy to adopt. It allows you to have platform engineers on one side, developers on the other side, and allow them, your developers, to just call resources using a single API. Also, as you are using a single API, it's API-driven, and that works as a product, right? And finally, it's scalable because, you install, and it allows you to deploy any resource that you require for your infrastructure. And in order not to bother you that much with so much theory, let's have a super quick demo. This quick demo comes from a KubeCon presented workshop on AWS. You can have the catalog later, or you can ask Shani and I. And within the workshop, there are many modules, but we are presenting an internal developer platform. And we are using not only Crow and ACK, but we are also using Argo CD. We are using Backstage in order to have a catalog of these resources. We are using Crow or kubevela for the composition of resources. And then we have a hub cluster talking to spokes clusters, both dev and prod. Okay? But within the demo today, we are going for something easy. We're going to have one developer going to Backstage catalog and say, hey, I need an S3 because I need to test some feature I just built. Cool, I go to Backstage. Backstage will call Crow, and Crow will handle all the resource management. How? Calling ACK, and ACK will manage to call the cloud and deploy that S3 that we required, that bucket that we needed in order to make our application to work. Now, in order on the resources that we have, just so that you check on Backstage, we have the component where we specify the thing that we are calling. Then we have the S3 bucket, the resource graph instance that the developer is calling. And then on the background of this, we have the resource graph definition of Crow, where we define the call to ACK, the S3 bucket, as well as we define some variables. And without further ado, let's check on that. This is what the UI of the workshop looks like. This content is free, so you can access it whenever you want. There are different modules, but the thing is that we go to the ACK one, and I just placed a video because there could be some issues with the internet, so it was wise to. Now I'm getting here a name for the bucket, just in order not to have problems with the naming. Here we can see a bit of how Backstage works. We build a template. Within the template, you specify what you are going to be building. First, the variables, so the bucket name, the environment, the prod, the region, etc., as well as the steps that it takes to deploy this resource. It's kind of a pipeline, but it is what it is. Then we also have the Backstage component I was talking about, the S3 bucket that will be calling Crow. I'm just highlighting a bit of the syntax, and then we have the resource graph instance that we will be calling. Okay. Cool. So let's see the Backstage catalog. I hope it moves. Yeah, let's go. Within Backstage, I don't know if you have ever played with it, but it's super cool because, well, it's also open source, and it allows you to have a cool UI for your developers to access whatever the platform team builds. So it's really, really cool. We place here the bucket name. We place a bit more information in the variables. We have that steps pipeline deploying. Also, it is connected to Argo, but just disregard, not important right now. And if we wait maybe a minute or so, 3 refreshes, and there we go. Now, we don't have to wait for days or weeks till we got our bucket. Within a single minute, this is proven by all those teams, compliance, platform, whatever. And we could enable our developers to accelerate and focus most interesting thing, which is developing. So if you want to get, you can have the QR code. Also, we are doing this kind of public presentations, so you can join whenever. And results?
Okay, I hope that you will not disappoint me, and it will be dogs.
If I refresh, it works,
Yeah,
right?
yeah. So refresh it.
Ooh. I had to place my mobile phone's internet, so.
Yeah, I saw.
Nope, I'm connected to, oops, sorry. No, because the I don't know if it's a web firewall or what was blocking the request. Yeah, yeah. So why this loads somehow? Do you have any question regarding ACK, regarding Crow?
And just one slide that we missed, we didn't upload it eventually, but AWS just launched capabilities in last reInvent, if you heard about, which makes ACK a managed service and also Crow managed service. So if you don't want to, you manage it as an open source, there is like the managed flavor.
So I have a question about ACK or
Okay, so it's not working, by the way, so it didn't disappoint me. Okay.
whatever you create.
We are on top of our. We can continue the discussion.
Yes.
Eat is something. On a coffee break. So 15 minutes for coffee break.
Thank you so much.
Thank you so much.
Thank you very much.
And well, nobody is.
Well, yes. Well, dogs won, so.
Okay, so hello everyone. For those maybe know me before or never see me, I always like to say when I'm kind of the events that thank you for being here. Without community, there's no events. So I also organize events on Dublin, so I know how hard it is to get people, get the place, get everything sorted. So thank you so much for being here. It's as a co-organizer of other CNCF chapter, I'm very happy to be here helping this to even grow further. So before we start, I would like to propose kind of question or thinking, how many CNCF open source security projects exist today? So just, yes, it's an easy challenge, just keep it in mind. So I don't have a fancy app like they had. I'm sorry, I'm still the old fashioned, try to be against AI stuff. So just for a moment thinking is maybe A, 27 or until 47, B, 4874, or C, 7595. Hold your horses, just keep in your mind, okay? Easy? Take a look? Okay, time enough. So who here thinks it's A? Okay, some hands, nice. B? C? Oh, it's the first time that everyone really, sometimes I need to make a joke about people that are not paying attention. So thank you so much of that. So actually the answer is C. And from the time I built this presentation around like 9 months ago, it was 82 already. So yesterday I did a check on 86. Some projects also go out, but yes, there is a lot of them. So I'm Bruno Gabriel da Silva. I'm a solutions architect at a company called Upwind. So what we do security for cloud in Kubernetes. Funny thing, I also like to say some things about myself. I started with Kubernetes around 1.14 when Windows was released for Kubernetes. I know most of Kubernetes people like hate this word kind of crossed together. I was actually a passionate guy about Microsoft technology for my whole life until I discovered the dark side of open source Kubernetes. Then I was working in AWS. So if you guys don't like CloudFormation, imagine support CloudFormation on the AWS side. So this is my old friend from that time. People are like, oh, I want to do this. Yeah, I'm sorry, this is not supported. So good time to make the joke. I kind of mentioned before, I run the Cloud Native Dublin. So I always open looking for speakers, etc. So that's it. And today we're going to talk about picking the right tool to secure Kubernetes habitats. Why use day 2? Because there's a lot of talks to say survive day 1, the day 1, there's day 0. Okay, yeah, my cluster is running. Is everything good? The cat and mouse application is there, working. I use curl to deploy. So what now? How could we guarantee, for example, that no one uses an AI to destroy their app? So how we think this the next step of we did deploy, things are running. So what now? Working on security for several years, I got a lot of understanding, like, I talk about image, container, admission controllers, and sometimes we forget that because we are insert on this, we think everyone knows about that, or everyone is aware about that. Similar to the first speaker when he made question about LLM, vLLM, and techniques, as he lives this every day, every time, you start to think that everyone's in the same boat, similar idea. So I'm getting this together with other colleague. I discussed the idea of like why we don't do like some comparison with Animal Kingdom, some habitat idea. Also, this was a way to try to convince KubeCon people to accept our talk. So kind of do very out of the box idea. And this is why I propose this, which is going to be talk about the tools, but actually do some correlations. That's something people that know me and saw my talks. I always like to do human or nature correlation to get easy to get the concept. In the animal kingdom, especially, you can think like we have a lion and a tiger. They're very similar. They even are from the same family, but there's something things that differentiate them. The way they hunt, the way they search. The same applies for some technologies. We even mentioned about CloudFormation, Terraform. They're very similar, but they have some difference between those. So this is why I'm going to want to bring this in this talk. Also, of course, we don't have time to go over 80-something projects. Otherwise, we need like a full week, maybe, or even more. I segregate them in stages: build, deploy, start, and run. But also important, experience and community usage. There's a lot of projects that you are there that never saw about, never hear about, or they were promoted like years ago and they're just there. CNCF, of course, keep doing nice work to keep the projects alive, to see if then demote a project. But again, open source, community-driven, on free time is not, CNCF cannot obligate people to do commits. So this is why these specific tools were chosen. It's very important because the colors, I'm sorry if one person say, I'm sorry, colorblind, so I'm sorry if it's your case. I'm going to do another version. But working with security for workloads, especially in Kubernetes, I heard so many times people say, oh, I'm scanning my container for vulnerabilities. So many times. And I can get it. You are saying that you are scanning your container image for vulnerabilities. This is the first thing I want to make very clear. Is the difference between image, the green square, and the container. Container is when we talk about runtime, when my image become runtime layer, when these things become read and write. We're going to go back on the concept before, but this is very important. Of course, when someone said this to you, like, oh yeah, I got what you're saying, but conceptually, it's not correct. The image is static. So you know that when Docker starts works on my machine, works on yours, this is the main idea, because I create something that's immutable. And these immutable are composed by layers. So I have the layer 1, layer 2, layer 3, layer 4, and I have some of those layers. The layer 1, as you can see, all of these layers are read-only. So to prove they're immutable. Layer 1, we're going to get, for example, from Alpine. Layer 2, we're copying a configuration. Layer 3, we are installing or adding OpenGDK to it. And layer 4, I'm then copying my application, my app itself, to the image. Then we're going to build the image. We're going to get there in a moment. The thing about immutability between build an image and then become a container, we're going to see later. I like to compare when you're doing, like, for example, a recipe of a cake. I get, starting point, I get, I don't know, sugar, milk, butter, flour. Then I mix them together. I put in the oven. So it's going to be the building phase. And then, okay, the cake's done. Oh, I forgot to add sprinkles. I forgot to add something. You can add over, or you can do some changes, but it's not going to be the same. So this moment I need to rebuild. The same always with the image. If something goes wrong or not in desired state, I need to rebuild the image to get there. Very important thing when we talk about image, container, image, green square, image. It's the base layer. So all the container image, they're going to have a base layer. In this case, I'm bringing here what is the file system of an Alpine. You probably have heard or know about Alpine. Very fast talk about it. It's a very used distro of Linux for containers because it's very small and easy to be operating on that. So when I go to the build phase, again, I have a container image. I have the layers. So going back to my previous idea, imagine that I go to supermarket and I get a product, for example, I don't know, like a juice or something. I want to know what is inside. So I get the juice from the shelf and look around and say, oh, okay, there's this amount of orange juice, of course, of Valencia. Then going to be a little bit of sugar and this and that. So I want to know what's inside. The same idea, why we just could, or people do run trust on the internet and say, kubectl apply some GitHub project that it just seems to be nice. And I'm just putting this image inside my environment. I'm trusting someone that's come from somewhere to put inside. No, we need somehow to understand or verify what is inside of this image. This is where an open source project called Trivi. I know the last weeks for Trivi were not the nicest for people who work in security. They had like 2 or 3 very bad instances online about security, but it's still, if not the most, one of the most used open source scanner for vulnerabilities. What Trivi will do is kind of in 4 main steps. You're gonna first struct the layers. So remember the base layer, the copy layer, build the file system, because I need to understand, like, okay, what is OS? What is like OpenSSL feature, something like that, to different to my Python, my Java, this kind of stuff, which is the 3rd step to do the segregation. And then I compare with VulDB. What is a VulDB? Imagine that I have a package called Bruno.0.1. How do I know if there's a problem that there's several companies, even NVD, etc., that are maintained by United States government and other entities, which basically say, if you're using Bruno 0.1, be worried that there's a specific vulnerability that if I give a candy to Bruno, he's just going to follow you no matter what. So, well, maybe I need to update. Also, in the VulDB, you can enhance to say update to Bruno 0.2, because this is going to avoid him to just be, silly kid to just follow it. Again, as you can see, I love to do comparison with our daily lives, because I think this helps us to get the concept even better. Sorry, I made not that good position of the image, but here is kind of a result of a scanning looks like. We're going to see that I have different layers of the results, different finds of the results by type. So, hey, this is something about Alpine in that specific version. When I did the scanning, I didn't have any vulnerability, but I had in other package like pip or setup tools, and even Whale, we didn't have some. So it's very important, because when we talk about building container images, it's very common you have platform teams using a concept called golden image. So I create the template that's starting the foundation, then I share with the application team to bring their stuff over. This is why it's important to segregate which kind of vulnerability or the source of the vulnerability coming from. So the animal I chose to kind of represent Trivi is a raccoon, or have no idea how to say in Spanish. Can someone help me? What's the name? Oh, Guaxinim in Portuguese. Bapache. Okay, so yeah, this was really, really hard one. So the idea is really because, a raccoon, it's very curious. Like you go to a trash can. I mean, we don't have that much here in Valencia, but he goes to a trash can and he kind of knows his own nature, DNA knows the VDB to like, oh, this is plastic, this is something, oh, this is food, this is what I want to. So the idea to get raccoon and Trivi is, look inside your image or inside your dependencies, etc., to then understand what needs to be segregated, good or bad. I create a little update from this this part. This because Astra, because I got a lot of feedback of like, okay, how can we then get better on this? Like just trust run on images. You may have heard about Scratch, Dristerless, and hardening. Especially hardening has become more trendy in the security industry right now. I'm gonna go fast on the concepts. Scratch is really from zero. When you want to create like a Go package or something that is just specifically to this to run, you can use for Scratch, but it's a lot of work. You need to be worrying about certificates. There is no compile like GCC, so you need to be very hardcore Linux maintainer, I would say, to use. Then we have Dristerless, which become more famous, which is basically like, oh, okay, I have a Scratch with operational system, so starting point. Then usually you have a shell or something extra to help, or some companies remove the shell, depends, but the idea is like easier to then copy your code over to use. And hardening become a trend around the last 3 years. One is like, I want to be sure that this image it's fully proof of misconfigurations, doesn't run as root. So I do the whole checks about the image. For example, Nginx image runs on port 80. To run on lower ports, you need to be root/admin. Bad. So you have a hardened version that change the user. So do all that's best practices. And also people ask like, how can I get this? You need to be paid. No, there are some open source stuff. There's some free, not necessarily open source. For example, ChainGuard, they offer several images for free to start. Some are hardening, some are just very well curated. And something that I personally use myself a lot is moving from Alpine to Wolfie, because it's also based on APK. So the whole script you have using before for Alpine, you can use on Wolfie, but the development as a company behind, the updates are way more frequent and CV goes way lower. Why to use one of these images? To avoid to have starting points. So when you create your image, you already have problems in the creation date. This can help you a lot. What is the downside or problem with the building image and the build phase? It's a point-in-time snapshot. I said this today, it's awesome. In 3 weeks, maybe. Especially after AI, even harder to say. So we need to rebuild. And some of us here at DevOps, or like me, DevSecOps, is very nice to say, no, we rebuild the image every day, we keep building. If you work in enterprise, this is not reality. You have image years running, no one touches, it's working. Please don't deploy on Friday. Then we move the next stage. So we build nice. Then we go to the deploy phase. So even we talk the previous talk a little bit about the mission controller, etc. When I send a request to Kube API, so hey, Kubernetes, create a deployment call Eduardo. This goes to Kube API. Kube API receives. We're going to do some validations if I have permission, etc., etc. But the problem is that Kubernetes, when it was created, unfortunately, people on Google thought that the world is very safe, is everything awesome, we don't need to take about security in consideration. And then a lot of problems come from that. So then, after some releases, a admission controller came in place, which is basically like, send this to Kubernetes. Hey, wait. Let me take a look what they're doing here. I'm going to inspect. Some admission controllers can just take a copy. It's very common to use, for example, for admission controller to get logs. So whatever goes there, I get a copy, and this is being used for audit or, oh, why Bruno create a namespace? Why Bruno did that? Or we have some capabilities called mutating. It's basically like, I check what you're doing, you wait until I give permission. Okay, now you're going to change this prop, etc., and then go ahead. When this process is finished, Kube API then say, okay, yeah, it's all good, it's done, I received the final desired state, then I'm going to save to the etcd, the database of Kubernetes. So the tool here that I brought to talk about is Caverno. So probably have also heard about Gatekeeper. This was the most famous projects. Why Caverno? Especially for me, is because the way you write rules is also YAML, the DevOps language. So it's way easier to teach a let's say, Kubernetes fan how to process and create rules using Caverno. Also, Caverno can be used for mutating. One of the very common mutating things is I send a deployment to go to my cluster. Oh, you did not put like limits, requests. You didn't put tags. So I can block it, say, sorry, Miss Developer, like you're doing wrong. This creates a lot of friction. I can tell you this is a problem. When you block the developers, they will find a way to get there. They will hack the cluster. They will disable Caverno. So what admins or platform admins, as they explained before, are doing is, okay, this is the defaults. If you don't say, we're going to enforce this, probably going to not be enough for you. Then you come to us and say, oh, but did you put these values here and there? Then we go to agreement, and then we go ahead. Actually, working with security so many years, the most thing that I learned is you need to try to be as close as possible to developers or users. As more friction you create, more shadow ways they will find to bypass you. And the Caverno, how to explain this? I like, this kind of forest guy guards, because imagine you go to a trail and then, you go there, oh, I'm confident, I know what to do, I have the training, I watch YouTube about this trail, I know everything that could happen here. When I ride the trail, he stops me and say, hey, just checking. Do you have a map? Do you have enough battery? Do you have all of these checks before you go to the trail? Or the opposite. Hey, it's already 5 p.m. It's going to get dark. So get this lantern, give me your number, and then you're able to go. This is, of course, easy to illustrate to how could be mutating or just, getting a copy of it. Then we go to start. So I create the image. I send to Kubernetes. Before it really become a thing, there is the start process, where in the Kubernetes, we have secrets. For those who probably know a little bit about Kubernetes, you can also read the chat book that you're going to know a lot about this, is that secret in Kubernetes is not that secret. It's actually just base 64 to be easy to be safe on etcd. So just the name, I think they could use password or something like that, but yes, it's what it is. And how we use this on Kubernetes, most of the case, is when we have a pod, and yes, you see that here it's changed to blue, is a container, it's not an image anymore. Image do not process the runtime from Kubernetes, or I can use as environment variables. Maybe there's even new one that, outdated, but this is kind of the most used things on the Kubernetes side. The problem for that is rotating secrets in Kubernetes get very tricky because, of course, you can do a kubectl edit, update, or use curl or somehow, but still, it's a lot of interactions with kube API. And versioning secrets inside Kubernetes was not designed to do that. So you cannot roll back versions. You don't understand who make the changes. If you don't have auditability, you don't even know who did that change. This is why the external secrets operator is very handy, because he can do a sync from outside repositories to inside Kubernetes. So I brought one example here using AWS Secrets Manager, very used when you have like EKS clusters, but could be Vault, or you can even own your own Excel spreadsheet and maybe do some manipulation if you like. It's important to highlight that the external secrets do not change the nature of the secrets, meaning your developer that using Helm, Crow, whatever, they don't need to change anything, because I'm going directly to etcd, directly to Kubernetes, say, hey, the password before was Bruno, then base64 it, now it's just Eduardo. So this is the idea, is get it simpler to avoid problems. There are other projects that they do directly insertion of the secret on the pods, but then needs to have the extra work to change deploy, change YAML, use the CRD. So you need to create things over that complicate that already Kubernetes kube world. It's complicated by itself. So the animal to represent this idea was really hard actually to do this one. I need to chat a lot with AI to kind of come to a final, and honestly, not as I would like to. But the squirrel idea is something important, something, it's secret. It doesn't store where he lives. He stores in a place that he knows where is it. When he needs to go there, get the nuts, and then brings to him. So this is kind of the idea to understand that things don't change on this house, don't change in Kubernetes. Use the external things to get it. So we scan the image. We also use the emission policy, and we have our secrets rotated like shift. So we are safe, right? Right? Kind of. So we did build. We did the deploy phase. Then we start. Now we come to the runtime part. And again, remember pod, container, runtime, the image become an object, a running object. And if I want to understand what a pod is doing, so when people say I'm scanning my container, for technical people that work in security, you're actually saying that you are following the behavior of that specific container when it's running. So the image now has CPU in memory, is doing this logic, and now I'm following it. The problem to do that, mostly when this started, was using something called sidecars. So I need to change my pod to add a specific container to then try to mimic, or if using, for example, a void, this kind of things that change. So again, this is very tricky because I'm going to developer and say, hey, you remember that stuff that we chat? Yeah, there's a new line you need to add there, otherwise does it go ahead? Or you inject with the emission controller, and then the developer come and say that basically like, oh, before you change that, was not this problem. Was working fine until you decide to use that specific security stuff. Then, luckily, there's something very strong on the Linux kernel that you may have heard is trending a lot. It's called eBPF, Extended Berkeley Packet Filter, which is basically the idea to say use kernel module is very bad. If you use kernel modules before for more old-timer Linux person, you know that if you do something wrong with the kernel level, it's basically do blue screen of that, but Linux is just kernel panic. It's not that nice, not that line, but you really can kill the whole OS because a small instruction went wrong. With eBPF, it's a way safer way to do that. This all observability, security, networking, they're trending to this direction because it's more CPU memory efficient, plus safer to be used. The problem with this, again, is that, okay, we have a BPF, but I'm not a Linux kernel machine to understand syscalls, which is basically the way that user space talk to kernel. So when I open a file, me just like cat bruno.txt, what happened under the hood is like lots of process, lots of calls. They say, open this, hold the file, who has permission? This is processed on the kernel side. So to filter this, to understand this behavior, we have a help of a tool called Falco. So Falco is an open source project developed by a company called Sysdig, which basically does this translation of this complex Linux, very weird world of syscalls to human read, which basically say, hey, someone open a file on etcd or /etc. Someone tried to create a file. Someone open a shell in that container. This is a lot of syscalls combined together with like ptrace, etc., which the Falco has a simple concept, which is I'm going to use the BPF bridge or access to the kernel. I will mirror, as you can see here, we're all in the same layer in the kernel. And then based on rules, because if I warn you, each file someone touch on Linux, I mean, you're going to need a lot of storage. But if someone touches a specific file path that I need to be worried, like where my data of my customers are saved, or someone tried to change a port or something like a specific syscall combination, then you let me know, then you warn me. Another important thing to highlight is that, of course, with Cloud Native and Kubernetes is the biggest project, but Falco works on the kernel level. So it doesn't matter if it's a container, it's just a Linux machine, if it's a pod, a container, at some point, you're going to talk to Docker or Containerd that at the end will reach the kernel. And we have a saying when talk about syscalls and security that kernel never lies. There is no way you can, well, there is a very specific way, but very hard way to do an emulation of a syscall. So if I'm following what's going on here, I'm sure that I'm following what's happening in my whole environment. So if I have several pods, hundreds of pods, the same node, I only need one Falco that can run as a daemon, can run as a container, etc., and then going to generate event. When I say about runtimes, people say, yeah, I got the concept, but it's hard to manage. Falco is not that friendly. Yes, it's not easy as the other tools. But for some specific use case, like Ingress Nightmare and Nginx when it happened, it was not a CV because it was not a package problem. Was not able to get with the mission controller because it was not a Kubernetes problem, not a Kubernetes configuration. It's actually a logic inside the Nginx how they handle a specific request. So this is not something you can get by a CV. It's not something you can get by the mission controller. You need to get a behavior to say, why my Nginx ingress controller out of the sudden start to do netcat commands or try to understand what's going around in my network, or even worse, start to read secrets for other namespace that is not belong to him. So this indicates that a breach happened. This is where runtime is really important. And of course, prompt injection. I can get something, my AI running, my pods running something with AI. There's no CV, there's no code problem again, but somehow I bypass the logic of my LLM, and then I'm able to say, give me the environment variables, give me the API keys. Why my application that's just a front end start to run env commands or export commands? This again is a behavior detection that happens on the runtime when the container is running. So this is what Falco is very important. There's another famous project also called Tetragon, which is from Isoviolent. Honestly, in the community, is not that used. I think it's more the enterprise version that Cilion has a combination with Tetragon that's been used, but is also maybe a tool that you would like to investigate. Well, this one, of course, was easy. I mean, the name by the creator was an Italian person, which then Falco is just Falcon in Italian. So this was the easy one to get the idea of get animals. And probably this one you're going to remember, at least something you're going to remember for the talk. So the key takeaways, again, I said this several times, I guess. Scan image is different than scan containers. So now that you heard this 7 times at least, or 8 that I count, remember, scan image, static stuff, get this, scan. I'm 100% sure what's here is going to be in your machine when you download that image. When it runs, depends of the environment, depends of several stuff. So best practice can be enforced. I can use a mutation, I can use enforce to blocked. Keep use external vaults without using Kubernetes way. Again, there's ways you can inject directly on pods, but this bring overhead to teach people a new way. If, for example, they had Crow, if you change this, the application doesn't start. Then it's like a lot of problems outside that maybe you as a platform are not aware that's going on. So keeping as much as Kubernetes possible, which is even the Crow idea, is a really good practice. And if all of this fail, or we're not ready for that stuff, for example, for an AI, we have the runtime to go to the rescue, which is the final layer that this already happened. I'm sure this is a problem, so let's go and, for example, do an investigation. So I'm going to share the slides later with a little bit of links, etc., to help. And that's it for me. Thank you so much. Thank you for having me. Oh.
If you want to say something, this is the moment. We release a book. Well, again, this is our last for today. Thank you so much again for your presence. And of course, we'll try to do more frequently. I heard from someone from IBM that they have a room, bigger room here. So for sure, we'll try to do this more and more time. And big shout here to help us. And again, we have swag and we have the hat. Feel free, and we have a lot of food outside. So again,
for the slides, if you want to get the slides from the presentations today, you can just go to cloudnativevalencia.com. And also for future meetings, we're going to start posting hopefully in the next couple, so we have kind of a heads up as to when the next one's going to be. Also on cloudnativevalencia.com. So thank you all for being here.